So when you're dealing with a two-dimensional server in computational science, one of the things that I said is that it's like a jigsaw puzzle and that there are empty spaces. And so if there was no empty space within a jigsaw puzzle, you couldn't rearrange or reorganize the other tiles to form what you're trying to make. So this would be a pixel space. So it has space and time, length and width. So you have this empty space. And so when you work a jigsaw puzzle, you want everything to be in order, like A, B, C, D, E, F, G, H, I, J, K. So that's how I've labeled each of the other pixels within the overall pixel. And so all a pixel is, like I said, two-dimensional space. This is square, and it's a unit of the Euclidean plane. So when you are dealing with a two-dimensional server, you can't rearrange that server, just like you can't rearrange a jigsaw puzzle unless you have empty space existing in the problem set. And so the jigsaw puzzle is the problem set. It contains the elements to the problem, and those elements are what we're going to use to find the solution. So when you have, so this is already what a jigsaw puzzle would look like solved. But when you take that empty space and you move this tile in, let's say, or this tile, you have two different options, H or K. But you don't have option G because that's crossways. But so this is a flatland, and so like Edwin Abbott talks about. So when you're dealing with sliding that over, let's say you choose K. Now let's say that you now have this as the empty space. So you're gonna move. Let's say you're still trying to solve it, so you're going to put, or you're trying to scramble it, you're going to put the G in, and then this is the empty space. You could also have put the J in, or you could put the K from over here, and then once you get to here, you went from 2 choices to 3 choices, and now you have the C, the F, the H, and then you could always reverse your move. So when you're dealing with this, you have 4 options in a jigsaw puzzle at this point. So the algorithm is a good example of choice theory on how to solve a jigsaw puzzle, because you're making choices that are unitary as far as the formulation. You're doing the slide rule of you're moving the slide of the square. And so when you're dealing with real space, you're dealing with the projective plane in geometry. So you're dealing with the z vector. And so you can think of that being a voxel, much like a Rubik's Cube. But if we still keep the jigsaw puzzle theme, let's say that this is an empty cube, and then this, we'll put A here. And the A is a 3-dimensional A, or a 2-dimensional A in a 3-dimensional space. And a voxel is formed of voxels, and that's what you're dealing with. So you would still slide the boxes over, like if you, kind of like if you were packaging and you were storing boxes or stacking boxes onto a truck. And so this is a 3-dimensional server, and these are all memory spaces. Now, one of the questions you ask yourself is, does the data in this context, this voxel, this space, defined by the dimensions x, y, and z, is this part of this voxel, or is this item actually existing in the voxel space. So one of the things to think about is, just like the jigsaw puzzle, if you have all the spaces filled, the full memory, you can't slide these boxes over. You can't reorganize the voxel, the space. So that's why you know that there is at least one empty voxel in our universe, because our universe is constantly rearranging unitary units in space. So that's why we have things like wind and why temperature moves from one physical system to another. And if we didn't have empty space in this universe, or a vacuum, we would essentially be in a sense of memory like gridlock. And that's why you can think of the universe as being like a server with random access memory. But yeah.